All right, welcome back. So far we have modeled a gene, which is just a point on a Cartesian plane, city. We have also modeled a chromosome, which is just an ordering of those genes. And we've defined several behaviors on a chromosome, like crossover and mutation. And now I'm going to define a new class called basically a TSP population. So a population is just going to be a list of chromosomes, right? So let's say new Java class TSP population. Okay, so we're going to say private list of TSP chromosome population. Let's import our list, private final int initial size. It's going to be the initial size of our population. And we're going to say TSP population final TSP gene. We're going to get our cities points. And we're going to get the initial size. And we're going to say this dot population is equal to, oh, I called it populatin, okay, is equal to init on the points and the initial population size, or the initial size, and this dot initial size is equal to initial size, right? That's all we're gonna do there. And we're gonna say for a given population, TSP chromosome, find a way to get the best solution. We'll call it alpha. Get alpha, return this dot population dot get of 0, which should be the best sorted value in the entire population, right? And we're going to say private list of TSP chromosome init TSP gene array points. This is the method that we use just above us. Final int initial size. So we're just going to say final list of TSP chromosome. We'll call it the Eden, right? The initial population, Eden, is equal to new array list. And for int I equals 0, I less than initial size, I plus plus, and final TSP chromosome. Chromosome is equal to TSP chromosome dot create points. That was the method that we had before. And Eden dot add the chromosome. So we're going to create a random solution and just say return Eden, right? So we're just going to create a random population using this create method that we wrote in TSP chromosome. And let's say we're going to have a method called update. It's going to update our population, and it's just going to call do crossover, do mutation, do spawn, do selection. So those are the only methods that are left for us really in order to, to work in our program to work. So we need to get to the business of implementing these methods. So the first thing that I'm going to do is I'm going to look at the do crossover method, right? So we're just going to say final list of TSP chromosome new population is equal to new array list. And for final TSP chromosome in this dot population, and we're going to say final TSP chromosome partner is equal to, and we're going to write a method, get crossover partner for this chromosome. And we're going to say, once we have that partner, we're going to say new population dot add all arrays. I'll explain this in a second. Dot as list and chromosome dot crossover the partner. Right? So all we're saying is add to the new population the result of doing the crossover, which is going to return an array. Remember, it's going to return an array of 2 new chromosomes. So we have to call arrays.asList to add it into the new population, right? And then after we finish doing that in the for loop, outside of the for loop, we're going to say new population dot add all this dot population, so we don't lose the existing members. And this dot population is equal to the new population. Okay? That's all we're going to do there. So we're just going to add to the existing populate. We're just basically going to add new populate. We could have, I guess what we could have said, instead of doing all of this, I guess we could have said this dot population dot add all new population, and that would have been it. And then we wouldn't need these 2 lines. Minor optimization there, right? So that takes care of crossover. So let's say, what about the method of doing mutation, right? So do mutation, we'll say final list of TSP chromosome, new population. Again, more boiler. This is actually exactly the same line. It's so boilerplate. And so support int I equals 0, I less than this dot population dot size, and I'm going to say divided by 10. We're only going to mutate a certain percentage of the population, right? We're not going to mutate everyone. And TSP chromosome mutation is equal to this dot population dot get TSP utils dot random index, this dot population dot size, and we're going to call dot mutate on it, right? And we're going to say new population dot add the mutation, and again outside of the for loop we should say new population, this dot population dot add all, or just add all new population, right? So that is that. And now we want to do spawn. Should be very easy. Do spawn is just going to say, and we're going to use some Java 8 syntax. We're going to range over the number 0. We're going to create 1,000 new individuals each generation. Get some fresh blood in the population. This dot population dot add TSP chromosome dot create and TSP utils dot cities. Right? Just a one-liner that adds 1,000 new individuals. And Okay, so the last method here is selection, and we're going to say this dot population dot sort. We're going to say comparator dot comparing double, and TSP. We're going to use a double to do the compare. TSP chromosome dot calculate distance. Right. So now we sort using the comparator function of calculate distance, and this dot we're going to sort our population that way based on the fittest individuals, right? So this dot population dot stream dot limit, and we're only going to keep this dot initial size and collect collectors dot to list. Okay. So we're only going to keep, we're going to kill off, we're going to keep the size of our population constant throughout the generations, and we're only going to keep the most fittest individuals, the ones that have the shortest distance, right? And I actually don't remember if the default sorts it ascending or descending. Let me see. Sorts the list according to the order induced by the specific comparator. Well, we'll double check that, but I'm fairly certain that that is correct. But we can double check that to make sure that it's sorting it properly. So now we have selection, we have update, we have the alpha method, we have the spawn, mutation, crossover. I think we still need to write the crossover partner. Right, I need to generate this method, so let's create that. So, okay, so all we're going to say here is TSP chromosome partner is equal to this dot population dot get TSP utils dot random index, this dot population dot size, right? And we're going to do the same thing where we say while the chromosome is equal to, well, this one we want to call this while the chromosome that we pass in is equal to the partner chromosome. We don't want that. We don't want to mutate with ourselves or cross over with ourselves. Excuse me, we don't want to cross over with ourselves. So then we say partner is equal to, and then you just do it again, right? So we're just going to keep trying, right? And then we're going to say return the partner, right? And that should be that, right? So now we have written out all that stuff, and we're going to go to the world, right? And in the world now, we're going to say, we're going to introduce private final TSP population, and we're going to say this dot population is equal to new TSP population, and we're going to give it the cities. Right, and we're going to say we're going to want 1,000 to begin with, right? That was the initial size. And now in here, we're going to say this dot population. On each iteration of our timer, we're just simply going to call update, right? And I think that should do it. We still have to draw the best chromosome that we have. And keep track of the shortest path, right? So, So let's introduce a method here after this. We're going to say g.drawString shortest path, and we're going to say string.format %.2f this.population.getAlpha calculate its distance. Tell me what that is, and we'll do it at 515. Right. So there we go. Okay. And then we're going to write a method called draw best chromosome into the graphics, into G. Right? And so we need to create that method. So we're going to say final list of TS, this should be quick, final list of TSP gene DNA, right? This is like the contents of the chromosome, let's say, is equal to this dot population dot get alpha dot get chromosome. Actually, let's just call it the chromosome, just to be consistent. Wait a minute. Ugh. All right. We're going to say g.setColor to white, and then we're going to say for int I equals 0, I less than, let's say chromosome.size -1, I plus plus, right? And we're going to say TSP gene is equal to the chromosome.get I, and TSP gene neighbor is equal to chromosome.get I plus 1, right? And graphics.drawLine. Oops. G.drawLine. And what we're going to do is we're going to draw the line, and then we'll draw the points. So we're going to say gene.getX, gene.getY, neighbor.getX, neighbor.getY. We'll draw a line. Very simple. Then we'll say g.setColor to red. And then we'll say for final TSP gene, and chromosome. Now we'll draw some points for each of the city. We'll draw them as red dots. Fill oval. G.fill oval. Gene.getX. Gene.getY. And it'll be a fixed size of size 5. How's that? Right? So I think that should do it. It's moving awfully slow. Maybe we just need to give it more memory. I did run it at a fairly big size. So let's see if I can kill this and then come here and say let's run configurations. Let's say -xms 1 gig dash XMX, 1 gig dash server. Let's see if that helps with performance. If not, what was my timer sleep? I do have a short sleep. Okay, I'm going to have to triage this. So we'll look at this again in the next video.